In this lesson, we're going to talk about triggering of the distributor and a variety of different distributors that are out there. We're going to be focusing on conventional ignition point and throughout the electronic distributor configuration. We will not be talking about distributorless ignition or coil on plug. So specifically, we're going to talk about ignition points through the latest in both conventional and race application distributors. So let's get started. So first thing we have here is we have an old mechanical distributor with point ignition. This is actually out of a 1969 Camaro, so it goes back a ways. And how we have it set up here is to the test board. So the test board is going to simply take the place of, and the headlight on the test board is going to take the place of an ignition coil. Just your run-of-the-mill conventional ignition coil. And when we see this light illuminate, that means that would be the same as if the ignition system was energized and saturating the coil. That will make more sense to you as we go along. So let's go ahead and try this out. We'll turn the system on. And then let's go through the wiring, how I have this set up. So we ended up having a very simple configuration. This black wire is our battery negative. I simply hooked it here to the body of the distributor. The other wire coming out, and that would be the normal one that you'd see out of in this case, out of the bottom of the distributor, is going over to the negative side. This is going over to the negative side of our ignition coil simulator. So let's go ahead and get this going. So I'm using a drill, and the drill will be able to drive the distributor up to what would be equivalent to 800 RPM engine speed, or think about that, distributor runs at half that speed. So let's go ahead and run this. As you can see by the flickering light, it tells us the points are turning on and off. Now as I stop it, I'll turn it just a little bit here. Now the points are physically closed. So it's just working like a normal switch that you would have anywhere. You simply would turn the switch on. In this case here, the ignition points have physically closed, and it's keeping the light illuminated. I want to take special note at this point here. We're looking at our voltmeter on the lab scope. So the line across the bottom is indicating what the voltage is at the ignition point. And so let's start from the top. That would come in through the power, through the bulb, from the bulb to the ignition points. And at that point, the points are closed, so all the voltage is being consumed through the headlight, or if we want to think about it, the ignition coil. So if I go the other way, at this point here, we're at system voltage. So it's what the battery would be providing to the ignition coil, again running from the plus side of the battery through the headlight and down to our distributor with the points open. So we're seeing the voltage is high. Now let's go ahead and run this, and we're going to run it at that speed I had described earlier. When you look at the waveform, when the waveform is down in this condition here, if you remember, that is when the points are closed. And when you're on the high side there, that's when the points are open. So it's a simple mechanical switch. But take specific note here, in this particular case, since we're ground side control, the coil is only turned on for a small amount of time in relation to time that it's turned off. That would be your dwell or duty cycle, the length of time that it's turning the coil on. And that is something that we have to be aware of. That is usually in the old mechanical days, you would simply adjust. In this case here, a Delco style distributor, you would adjust the screw while it's running and achieve a specific dwell setting. Often utilizing a dwell meter was the most appropriate. We're looking at this kind of a high-tech approach, but this is exactly what's going on. Now, we're not seeing in here would be the coil discharge and all that. So that'll be covered in a future lesson. But right now, we're just going to simply look at this as a switch. Okay, let's go and run up the distributor and want to slowly increase the speed. So take a note of the lab scope and the light and how it illuminates. So a very slow speed, and as I increase the speed, as the speed is increased, we notice that the light now, you can barely see the flicker in it. What that is representing is, remember, you got to saturate the coil and discharge the coil. It's got to happen faster and faster and faster. So this just gives you a visible illustration of both the ignition, you're looking at the lab scope portion of it, and the visual portion of looking at the light. This next session, what we're going to do is we're going to be looking at an induction style distributor. So that's going to have a pickup coil on it, and what it's going to do is it's going to generate a small AC signal. So this particular case, there is no ignition module in this distributor. So it's going to use an external triggering device. An external ignition module is going to be needed. In this particular case, we just simply set up a transistor on our test board with an NPN transistor. And the first thing we're going to test here is we're going to have the lab scope set up. So I'm going to be looking at the trigger point. Now in this case here, it's going to be supplying a ground, and when the ground's applied, that light will illuminate. So we need to, in this case here, we can't just simply turn the distributor because nothing is going to happen if we just simply turn the distributor. But if we spin it, we're going to get enough induction off of the pickup coil to trigger that transistor, that would be your ignition module, into this point here where we're looking at the ground side of the circuit. So let's go ahead and we're going to go ahead and run it. So I'll spin the drill up, and then see here the cycling as the transistor turns on. As I gain speed, gain additional speed. So one of the things we got to take specific note to is in this particular case, if we left the ignition key on, there would be no energizing the coil. Where with the old point ignition, one of the problems is if you actually left the key in the run position, then put it in the accessory position, you would actually could have the points closed. You had a percentage chance that the points would be closed, and if the points were closed, you would actually sit there and simply heat up the coil and shorten its life, and you could actually put stress on the points. Now they are replaceable, but that ignition system had a frailty, but it had been around for 100 plus years. So the electronic ignition made a significant difference in that perspective. So again, from the top, as we spin the distributor up, we increase the speed, and you can see the frequency of the light bulb, very similar to when we're using a large one. In this case, we're using a small little LED. Now let's go ahead and look at the next section out of the triggering at the pickup coil itself. Now I've made some modifications to the scope. I've actually set it so our zero is right in the middle. The reason for that is we're going to be looking at an AC signal. It's going to be above and below ground as the distributor turns. So let's go ahead and spin the distributor. So as this distributor is turning, I want you to take special note here that even in this particular case, cranking the engine, if that was cranking the engine over at a low speed, you would still be getting your ignition firing. But that is critical for the distance between the pickup coil and the reluctor wheel. That clearance is typically, say, and this would be in thousandths of an inch, 8, 10, 12 thousandths of an inch. When you get the specification, it's critical that you actually make sure that setting is correct. And where that will be a problem, it'll start for you in the bay perfectly when it's warm out. But try out when it's extremely cold, and you may have, at really low cranking speeds, you won't have ignition or adequate ignition. You'll have maybe intermittent pulses as the distributor turns over. So again, that is a key. And number 2 is that component is a wearable item. The pickup coils do fail. So keep that in mind, because that is something that you might very well be replacing. So one more review. As we speed it up, the length of time, these are more precise, and all of the control in this particular case is done with that external module. So you got to remember that. This is the pickup coil is incapable of triggering an ignition coil. That is not something it's capable of doing. It's going to need an external module, and in an external module you're going to have a transistor. That's how the whole operation is going to work. This next distributor we're going to be discussing is kind of a very common distributor out there, a Hall effect style. This particular distributor is out of a 5-liter Ford. So it was an HO 5-liter Ford. I have the ignition module removed. So we're strictly going to be talking about the Hall effect switch inside. And that simply uses a chopper wheel to bias a transistor. So magnetic field turns on and off, so not much different than the transistor that you see here on the board. But that small little module inside there. And the way I've actually hooked it up here is I have my ground, my power, and then I have my control wire that would be going to the module. That would be your PIP, profile ignition pickup. And what we're going to be doing is going to the ground side. So this is going to be, the distributor is going to supply a ground to the LED light. So again, it's a low current device. Separately, there would be a high current device that would be turning on the ignition coil. So from the top here, power will be coming through. It will go over here. Power will be coming through. It's going to ultimately go through this LED light, and the ground is going to be provided by the distributor. Since the distributor would normally be in a engine block, I put an auxiliary ground to it, so the transistor has a ground connection. So that is why the duplicate ground, where we have a ground coming in here and the body of the distributor itself. So let's go ahead and we'll take the distributor and we'll rotate it, and you can see the light is illuminating now, so it's biasing our transistor. And as I turn it, you can see as we rev it up farther and farther and farther and farther, just as a little side note on this particular distributor, this was out of a sequential injected 5-liter Ford. In this particular case, it has a signature pulse to tell the injectors at what cylinder they're supposed to fire in. So if you don't see this smaller square wave in it, it would be a group firing injection system. Just a little side note. So let's go ahead and we'll disconnect our drill temporarily. And now look if I turn. Now, What did we learn when we talked about points? In the case of the ignition points, if you left the key in the run position and the points were closed, we could heat up the coil. So if the points were closed, we could heat up the ignition coil. The same thing is potentially true with here. So they're going to rely on the module itself to either switch it off or allow it to cook. That's a lot of heat. So there's different configurations, but I'm just saying within the Hall effect configuration. So that's really our main objective. It's either biased and turned on or turned off. It is literally that simple. So very similar to the point ignition system. In the next configuration here, this is going to be a Mallory Unilight. So that is an LED style distributor. So it's going to emit an LED light, and off that LED light it's going to use a photo absorption cell, bias a transistor, and simply be able to turn the system on and off. In this particular case, it is a full current load design. I'm going to utilize, just for simplicity here, so you can see the speed at which it turns on and off our LED, but it can carry the full load of the ignition coil. So let's go ahead, and within here we have our LED light, and there's a chopper wheel. So this one requires to have the rotor in place. So the rotor needs to be in place. That's where our chopper wheel is. And as you can see, as I turn it around, my voltage here is simply going high and low. So when it goes high, the light's not illuminated. When it goes low, the light's illuminated. Now we'll spin it with the drill to get some RPM on it. And as you can see from our waveform here, this is leaving the coil on for an extended period of time. So this has a long on-time duty cycle. So when you're utilizing something like this, you got to make sure that you're choosing the right coil for saturation based off the engine RPM. Now in every case here, we're running the drill up to duplicate an engine crankshaft speed of approximately 800 RPMs. So this might just give you kind of a point of reference what's going on here as far as the speed. One of the advantages of this configuration, it's not prone to electrical noise like you would have more so with the Hall effect, and specifically with the induction coil style. And of course it's really, really, really fast. And if you want to think about it, you could simply change your duty cycle of your distributor. You're not going to be grinding this up, but I mean, if there's an offering, you could actually just change the width at which these are to dictate how long the coil would actually be staying on. And if you look inside here, we just simply have an LED light module that's full current loading capable. So there is some real advantages to this design. There is some disadvantages to the design, and one of them I can tell you right now is the biggest problem that you can run into with these is the situation where the distributor gets dust and corrosion in there, and it's blown around and coats the eye, and then you can cause a situation when you have a mistrigger. So something to be very aware of. That is a possibility that could occur. So if that's being used, and it does need to have a certain amount of preventative maintenance. In the next configuration here, we're going to demonstrate an MSD Pro Billet distributor. This is kind of a high-end distributor for more of a race application, or at least an on-road high performance. A couple things that are unique about the MSD. Well, first off, it uses the standard pickup coil, kind of like we introduced in our second section there. So we have induction coil, and it's going to be going to look at these slots, so it's going to produce an AC sine wave, but there's an integral module in here, and that module is capable of operating the distributor. So in this particular case, I decided to hook that up to the regular headlight, and I want to show a couple things that are unique about it. So we'll go ahead and we can just even turn it by hand. I'll go ahead and put the drill on there. With the drill, you can see we have this square wave here. So the length of time that we're on is when the voltage is being pulled down. So it's had a longer duty cycle. But I want you to take special note of something here. This is what makes these distributors unique. Called multi-strike. And what this distributor does, the multi-strike discharge, is it fires the coil very rapidly many times at very low speed or excessively high loads. And what that is capable of doing then is to make sure that you did have an ignition firing. So if you're involved with a race application where you may have heavily cammed engine, where they're not going to be very stable at idle, this is a premium choice to allow engine stability, where normally a conventional ignition is going to be struggling to make sure the firing of each spark plug is adequate at the right time when you have a mixture in there. With the multi-strike, if you don't have the right mixture, you've got another try and another try and another try. So it is a superb design from that perspective. There is one minor downside that I have experienced with this configuration, and that is more rapid spark plug wear. That's the only thing I've ever seen, but it is something to be aware of. So the setup here was simply we have a negative, we have our positive coming in. In this case here, I hooked it through a ballast resistor, or simply a dropping resistor, and so my lap scope was hooked up here, and then we're supplying a ground, so power is coming in to the headlight, and then through the ballast resistor to ultimately ground it in the distributor itself. So it gives you an idea of how the circuit flow works.